We have issues to do with increasing nutrient availability, improving stress tolerance, improving plant defense immunity, or what we call the plant immune system of a crop. The fundamental basics of any crop is to try and capture all that genetic potential that is in a seed. So that's where biostimulants actually come in. My name is Ronald Rusere, and I'm a technical agronomist and consultant. In this episode, we want to talk about biostimulants, and it's an introduction, and why farmers should actually adopt biostimulants in their cropping systems. Hashtag going for growth. This is only an introduction because the topic on biostimulants is big, and we're going to break down different categories or different topics under the biostimulant topic as well. So this is just an introduction so that you get a feel of what biostimulants are, and you actually provoke those thought-provoking questions in your mind on why do you need biostimulants and how you are going to integrate them in your systems. So when we're talking about biostimulants, we talk about efficiency, efficacy, and effectiveness. These are three key words that we usually run with. So efficacy and efficiency, we're talking about reducing fertilizer applications and actually getting even the same or more yield. Reducing chemical applications when it comes to pesticides or insecticides, but actually improving the resistance of that crop to diseases and actually improving that resistance of that crop to pests. So that's a key area in which biostimulants can help a farmer in increasing profit margins. The topic on biostimulants is not something which is new. It is something that has always been there from time immemorial, because our grandfathers or even our ancestors used to use even organic matter. So with biostimulants such as humic acid is also a result of decomposition of that organic matter. That's when you have humic substances such as humin, humic acid, and fulvic acid. So it is something that has been done from way back, but it is now we are sort of going back to the natural ways, because we've been using so many synthetic chemicals, actually disturbing the systems. For instance, we've been using too much of those artificial fertilizers, but at the same time getting less response from those soils, which means we have disturbed the natural ecosystem. How have you disturbed the natural ecosystem? By adding too much nitrates in the soil, they actually burn off the carbon in the soil, resulting in less organic matter in those soil. Two, they actually kill the microbes in the soil, because if you add a lot of soluble phosphorus, it actually kills even the beneficial microbes that solubilize phosphorus as well. So with biostimulants, we are trying to revert back to natural methods that we have been using and integrating them with our current systems so that we improve the efficiency of our cropping systems. So please note, excessive use of synthetic fertilizers actually result in a number of key issues that I've mentioned. But biostimulants actually help in trying to counter-effect those problems that arise from the excessive use of synthetic fertilizers. So let me give you a practical example on how some farmers have been integrating biostimulants from way back. So we have got cane molasses. Cane molasses has been used by farmers, especially farmers which grow soybean. With soybean, farmers actually use rhizobium. Rhizobium is a bacteria that fixes nitrogen. But this bacteria also feeds on cane molasses in the soil. So a farmer can actually apply cane molasses in the soil if they want to provide a food source for the bacteria, and also if they want to multiply those nitrogen fixing bacteria in the soil. How is it important? We've been buying a lot of nitrogen, but already we have free nitrogen in the atmosphere. 78% of the atmosphere is nitrogen. That is why every time when there is a rainfall event, everything turns green, because lightning actually oxidizes that nitrogen into available forms of nitrogen. But with rhizobium actually fixes that nitrogen in the air and makes it available to the plant. So farmers were actually using cane molasses to provide a food source for the bacteria. So first, what are biostimulants? When we talk about biostimulants are organic molecules that when used in small quantities can improve the efficiency of a crop as well as the yield. So how then do farmers use biostimulants in their systems? There are so many challenges that farmers are facing at the moment. We talk of leaching, we talk of inefficiencies in terms of fertilizers, we talk of stress that's affecting yield as well. We talk of any other factor that's limiting yield. When you integrate biostimulants in your system, you are trying to minimize stresses and actually improve the physiology of the crop so that it performs at maximum. So one, what are some of the limitations that farmers are facing right now? We've seen that we've had a lot of rainfall for a really good period of time, and this rainfall actually results in leaching of nutrients, especially nitrogen and phosphorus. So when there is leaching, it actually reduces the yield of that crop. Therefore, how then do we minimize leaching and actually make use of our fertilizer? Because actually fertilizer is very expensive. So you can use what we call humic acid or humic substances. With humic substances, they actually stabilize that nitrogen and that phosphorus so that it becomes bound in the soil and available to the crop. How do they stabilize that phosphorus or the nitrogen? Nitrogen is negatively charged as well as phosphorus. And our clay colloids or even the silt colloids are negatively charged, which means these nutrients are actually soluble and they can leach from the soil. So if you use humic acid has a lot of positive charges sites and also negatively charged sites. So it actually binds even what we call cations, which are positively charged nutrients or elements, such as magnesium, such as calcium, and also it also binds the negatively charged elements, which are your nitrogen and your phosphorus. By so doing, it minimizes leaching. So you have all of your nutrients in your soil, and with that, most of that nutrient is going to go to the crop. And another way, you can actually minimize your cost as well, because research has shown that nutrient use efficiency for NPK, for N alone, it's 50%. For the phosphorus, it's 10 to around 30%. Then for potassium, it's around 40 to 50%, which means if a farmer is buying like 1,000 kgs, only 50% of that 1,000 kgs is going into the crop. Only 10 to 30% of that phosphorus is going into the crop, and only 50% of potassium is going into the crop. So it's not what you put in that really matters, it's what gets into the plant. So biostimulants can actually help in improving that efficiency of getting all of your fertilizer or most of your fertilizer into the crop. By so doing, you actually get a return on your investment and also a bigger yield. Also, you can actually reduce that fertilizer as well, because if only 50% or 70% of phosphorus isn't going into the crop, so imagine you've bought your phosphorus and within the first 4 weeks or within the first 40 days, most of that phosphorus is locked up in the soil, which means it is not available. Therefore, it becomes like a frozen bank account where you can't access that phosphorus, but yet you've bought that phosphorus. So that's where biostimulants can come in, such as humic acid, that actually binds that phosphorus so that it becomes available to the soil and minimizes leaching, especially during times where you have incessant rains, or for farmers that have soils such as sandy soils that have a low nutrient holding capacity and also a low water holding capacity. You can actually improve that with biostimulants such as humic acid. So what humic acid does also, it also sensitizes the roots. When you say sensitizes the roots, it means the roots open up more ion channels that can actually speed the uptake of nutrients. It actually improves the uptake of nutrients by 30%, which means there's more uptake of those nutrients by simply using humic acid. Also, Humic acid also promotes root growth. When you have a bigger root growth, then you've got more access to water and nutrients, which actually improves in terms of stress tolerance, such as drought, and also water and nutrient capture as well. Because in the first days, we want a crop that has a high root dominance. Why root dominance? Because we need a crop that can access water, that can access nutrients, and as long as a crop has a healthy root, it's a healthy plant. As long as a crop is root dominant, it's a healthy crop as well. So in the first few weeks from germination and emergence, the first priority is shoot growth and also root growth as well, so that we try to capture all those nutrients that we have applied. Then another issue as well with the humic acid as well is that you can actually use it to actually improve the efficiency of your fertilizer, such as urea. Urea easily volatilizes when it goes on the surface of the soil. So when you add humic acid or humates, it actually stabilizes that urea, and it forms a urea-humate bond, which is stable, which doesn't volatilize, and which is slow releasing, that you got your urea throughout the season. So it's another way of improving efficiency of fertilizers as well. Then another biostimulant that we can talk about is fulvic acid. We've got a longer period that we've been facing cloud cover and incessant rains. One thing that a farmer cannot supplement, you can supplement everything. You can supplement nutrients, you can supplement water through irrigation, but a farmer cannot supplement the sun. So with fulvic acid, it's nicknamed the second sun. So how does fulvic acid improve the physiology of a crop? It is called the second sun because when you apply fulvic acid to a crop, what it does, it improves the photosynthetic level of a crop. Because as a farmer, what you are trying to do is managing the equation of life, which is the photosynthetic equation. As a farmer, you are trying to manage photosynthesis, that your crop is a higher photosynthetic rate, because this is the equation. Sunlight drives photosynthesis, and photosynthesis drives yield. So if a farmer actually improves the photosynthetic level, you're actually improving your yield ultimately. And also, when a crop is performing well on photosynthesis, it can easily defend itself from diseases as well, because there are many volatile compounds that are produced, as well as some defense compounds that are produced in a plant, because a plant has its own innate immune system. So if it's fed well and it gets the right nutrition and it's photosynthesizing well, that crop can be healthy and can easily defend diseases. So with fulvic acid, one, we can use it as a supplement to supplement the sun, because whenever there is cloud cover during those periods of incessant rains, with fulvic acid, your crop can actually photosynthesize well, even there is low cloud cover, which actually improves the Brix level. The Brix level actually measures the level of photosynthetic activity in a crop. So fulvic acid is one product that you can use, which is another biostimulant that you can use to improve photosynthetic capacity of a crop. Also, fulvic acid sensitizes the roots as well, and it improves the uptake of nutrients as well, even in the roots. And also, fulvic acid can improve the efficiency of foliar fertilizers. How does it improve the efficiency of foliar fertilizers? We know that some elements are negatively charged, and the cell membrane of a plant is also negatively charged, which means a negatively charged cell membrane and a negatively charged nutrient. It means there's a delay or a slow uptake in the nutrients, since there is a negative charge to a negative charge which repel. So when you use fulvic acid, it acts as what we call a chelate. When you say a chelate, in simple form, we're saying fulvic acid actually surrounds that nutrient so that it neutralizes that charge, and it speeds that uptake during the cell membrane, because if it has a neutral charge, it's quickly absorbed. So in a way, it improves what we call the rain fastness period, because if you add fulvic acid to your foliar nutrition, it actually speeds up the uptake of that nutrient, so that even if there is a rainfall event after application, even a few hours, all your nutrients will be absorbed fast in the crop as well. And the plus side is it improves the Brix level of your crop. So when you're adding a carbon source, whenever you apply foliar nutrition, the rule is you should apply foliar nutrition plus a carbon source to improve, one, the uptake of that fertilizer. Two, carbon. From the word carbon, we know that plants feed on carbon dioxide. So when you're giving a crop carbon, it sensitizes that stomata so that it opens quickly. So when it opens quickly, it absorbs that foliar nutrition as well. So that's another advantage of using carbon sources when you're applying your nutrition. Quickly stimulate those stomata to open by actually giving that crop carbon so that it opens the stomata. Then you apply your foliar nutrition, which means it speeds up the uptake of that fertilizer as well. So that's another advantage as well. Then we have what we call B vitamins. It's another biostimulant that can be used as well. So with B vitamins, we know even in humans they actually consume B vitamins. So with B vitamins, there are enzyme cofactors. So whenever there are enzyme cofactors, be it vitamin B1, B2, B3, going upwards, these enzyme cofactors, with enzymes, they actually speed up the metabolism of a plant. So when there is a higher metabolism in the plant, the products that are formed, sugars, be it the sugars, the compounds, they're actually formed fast, which means your crop is actually performing at a faster rate, meaning there's a good and quick growth rate. So that's another advantage of using B vitamins. And also, B vitamins actually turn on the immune system of a crop. Each and every crop has an immune system, the same as in humans as well. So in the immune system, we have got two defense systems. We have what we call systemic acquired resistance, and we have got what we call induced systemic resistance. So what B vitamins actually do is that they turn on the immune system of the crop, so that the immune system is on high alert whenever a disease appears. So you have a crop that is actually ready to defend itself because it's been sensitized to be on high alert whenever a disease comes. So that's the first defensive mechanism that you can use actually to control diseases. Having your crop with a defense mechanism. Same as in humans. We can actually see that different people have actually different immune systems. For example, I can give an example of flu. Some people can even spend their whole year without actually falling sick. And some people can actually fall sick whenever a flu occurs. So it's all about the immune system and the nutrition that person is getting as well. So if your crop is actually integrated with biostimulants that actually turn on that immune system and the nutrition that is balanced, you can have a crop that can fight diseases as well through its own immune system. A practical example in which we can integrate biostimulants in order to improve disease tolerance as well is on blights. Many farmers are having challenges with blights during the rainy period. Whenever there is a rainy period, there is limited sunlight, which results in a drop in the sugar levels or a drop in the photosynthetic level of a crop. And that drop in the photosynthetic level of a crop results in what we call a low Brix plant, which is a low sugar plant. And pests and diseases are usually attracted to low Brix plant. So what happens in the case of blight? With blight, its present and expressions are two things. Blight is always present on the leaf surface of a crop, alternaria, but its expression depends on certain conditions in a crop. So if you look, I'll give an example of a pregnant woman. So when a pregnant woman, when the baby is growing, there's a huge demand for nutrients, which results in susceptibility as a result of hormonal imbalances in the body of the woman. So when the baby is growing, there's a huge demand for nutrients, and most of the nutrients are being channeled to the growing baby inside the stomach. This can be related to also tomatoes during the start of fruit fill, because at the end of the flowering period, potassium and magnesium peaks. So when potassium and magnesium demand peaks, it results in a shortage of photosynthesis that go towards the shoots and the fruits that are starting to fill. And the roots now decline in activity due to a shortage in sugars that are going to the roots as well. This shortage of sugars going to the roots results in an imbalance in hormones, because the crop has developed a scenario which we call auxin dominance. Auxin dominance is where most of the sugars are being channeled to the shoot tips and the fruits. Remember, auxins are attracted whenever seeds are being formed. So inside the tomatoes, seeds are being formed and they attract a lot of sugars, which result in the lower leaves of a crop, the older leaves of a crop, sacrificing their potassium and magnesium towards the new shoots. So this sacrifice towards the new shoots results in a huge disease susceptibility in a crop. You can notice even the timing of the blights, of bacterial speck, of leaf spots usually occurs during the beginning of fruit film, which shows you that it is also a result of nutritional problems during that period. It is also a result of a shortage of potassium and magnesium in a crop. And it is also a result of an imbalance in hormones. Plants are linked to hormones, and wherever there is potassium, there is auxins. So a shortage of potassium actually results in the susceptibility to a host of diseases. So how do you integrate biostimulants to try to minimize that problem? You can actually use products that contain phytohormones and nutrition. For instance, you can integrate with Humic. Humic contains auxins and cytokinins. So this helps in trying to keep a balance of those hormones in the plant. Because whenever you have a crop that has a balance in the hormones, it is actually not susceptible to diseases. 2, it has got fulvic acid, which can actually improve the photosynthetic level of a crop during those cloudy periods or those complete overcast periods where the sugar levels in a crop declines. So you have a crop that is actually performing at its highest photosynthetic level even during periods of shortage of sunlight, which actually helps in trying to minimize the problem that occurs during that time. That is why blights always appear when there is conditions of limited photosynthesis, such as cloudy cover or during those rainy periods. So that's another way a farmer can actually integrate biostimulants in a system. So you can use a product called Humic, or you can actually use molasses. How does molasses come into the play? Molasses actually helps because it is rich in potassium, calcium, magnesium, and iron. It actually helps in supplying that potassium during or those sugars in a period where the crop has a high demand of sugars. So you're actually constantly supplying potassium to your crop when you're applying molasses foliar. So this actually helps in trying to minimize even the use of chemical synthetics, because at times farmers have a problem that they're addressing the symptoms but not trying to solve the root cause of those symptoms, of those problems. So when you try to address the root cause, we actually help in minimizing our costs as well. So that is another way that farmers can actually integrate biostimulants in their systems. Well, farmers, thank you for watching. Remember, this is just an introduction. The agenda is simple: more production, more production, more production. From less land, less input. # going for growth. Then we have also other biostimulants that we can actually use called seaweed. So with seaweed, there are different types of seaweeds that are there. There's the brown algae, there's the red algae. So there are different types, and depending on the source. So the brown algae is actually what we call Ascophyllum nodosum, which is actually most common. And with Ascophyllum nodosum, it's a potent seaweed because what it does with seaweed, it actually improves stress tolerance. Stress tolerance is key in limiting yield. So whenever you have a crop that can tolerate stress, it actually improves that yield of a crop as well. Because we try to minimize stress, stress actually reduces yield. So when you have your seaweed, because seaweed is actually adapted to stress, because it accumulates proline.